Beautiful. Okay, so today's gonna be a short lesson, guys. It's not gonna be that long because mainly we're gonna go ahead and simplify imaginary numbers, and they're gonna be presented to us in a form of a radical. But we're gonna go ahead and see how does that work, or how do we apply that to what we already know. So simplifying imaginary numbers is what we're gonna go ahead and go into. So we still have complex numbers, we still have imaginary numbers, part of it. We have our beautiful values, and we already know that an imaginary number is going to be the square root of -1. Okay, now that we have I in place, we're going to go ahead and recall our beautiful skills on how to simplify radical expressions. I'm just going to bring it back so that we can go ahead and recall our steps here. Now, for the first one, we have square root of 16. How do we simplify this one? Square root of 16. So it'd be what? Square root of 4 squared, which is now what? Beautiful 4. What would be the solution for this one? Square root of 3 squared, which is beautiful 3. Now, identifying the perfect square that goes into it, guys, is also a way to identify how to simplify it. And also take in consideration that we're going to have the positive and negative solutions of it, because we have a beautiful radical. All right. Now, this was having perfect squares. What if we don't have a perfect square? What do we do instead? What did we do last time? We had to break it apart. Now, last time we did our factoring tree, so we were able to identify all of the factors all the way to the prime factors so that we can go ahead and identify the pairs and then find the possible square roots and perfect squares that we had in there. But this time I want you guys to think of the list of the perfect squares that we have. So for example, let's go ahead and start with 1. 1 squared is 1. 2 squared is 4. What would be my next one? 9. The next one? 16. The next one? 25. 36. 49, and so on and so forth, right? 64. And it keeps on going. I don't know why it keeps on closing my force. There you go. And it keeps going on and on and on and on, right? Depending on what we have here as a perfect square. Now, I want you guys to start using these as part of the factors that we're going to have inside our radical. In order for us to simplify. So how can we rewrite 18 with having one of the factors being a perfect square? How can we write 18? It would be 18 is what? 9 times what? Times 2, right? Because it's multiplying by 2, our radical can be separated into 2 congruent or to 2 separate radicals. So I'm going to have here square root of 9 and square root of 2. We already established that square root of 9 is a perfect square, so we're going to have 3 as a solution. So we have 3 square roots of beautiful 2. Go ahead and try 24. What's that perfect square or a factor that we have that is a perfect square in 24? So use one of these perfect squares as one of my factors. So try 1, try 4, 9, 16, 24, 36, so on and so forth, and see which one fits into that valley. Okay. All right, go ahead and share with your neighbors and see what you guys got. All right. So what is the perfect square that goes into 24? In this case, it would be what? It would be 4. So we have 4. Square root of 4 times square root of what times 4 gives you 24? 6. Now 6 doesn't have any perfect square as a factor, so we're going to go ahead and leave it as is. And what is a square root of 4? 2. So we have 2 square roots of 6. Again, if we need to rewrite this one so that it's 3 squared times square root of 2, we can go ahead and do that at a little extra step, okay? All right, ready to step it up? Yes, no, maybe so? Okay, let me leave my beautiful perfect squares there. I'm gonna go ahead and bring now a different type of example. Let's go ahead and say that we have a negative involved here, guys. What's going to happen? So our first example here, we have square root of negative 25. Now, remember that whenever we have radicals, we can separate our factors apart. Factors means all the numbers that multiply that number. So I'm going to go ahead and rewrite square root of negative 25 as follows. Square root of 25 times square root of negative 1. Can I do that? Yes, because they're multiplying together. All right. Now, what happens here? What is the square root of 25? 5. And what is the square root of negative 1?
1.
Hi. So this is going to be 5. Hi. All right, the next one. Square root of 121 times the square root of negative 1. What is the square root of 121? 11. And what is the square root of negative 1? 5. So this is 11. Oh. Yay. Yeah. Ready to step it up? Let's stay at this level forever. All right, everybody has this. Perfect. Okay. All right. Let's go ahead and try these now. Square root of 256, negative 256, and square root of negative 361. Go ahead and try these ones on your own. Let's see what you guys get. All right, Andre, pass it on. Joaquin, what do I do first, Joaquin? I have a square root of a negative number. So I'm going to do square root of 256 times square root of negative 1. Our square root of negative 1 is going to turn into I, and square root of 256 is, so it's going to be 16. Beautiful I. All right. All right, Joaquin, pass on the next one. All right, Lily. How do we do this one? And square root of negative 1. And this is 19i. Raise your hand if you got both of them correct, guys. Woo-hoo. Awesome. Okay. All right. Ready to step it up now. All right. Now, let's go ahead and try these now. What happens when I can't simplify the radical and it's not a perfect square? We're going to go ahead and apply the same idea that we just previously did. We're going to find a perfect square that goes into the values, and we're going to go ahead and factor or compute that perfect square and leave the factors that do not inside the radical. So remember, we have perfect squares. For example, we said 1, again, my list, 4, 9, 16, 25, 36, 49. I'm trying to recall them, guys. Sorry. 40, 64, 81, and so on and so forth. 100. What's the next one? 121. And then 144, and so on and so forth. Okay. All right. Let's see if any of these perfect squares can be a factor of those values that are inside. So for example, the first one, 245. So I'm going to go ahead and separate it first. Square root of 245 times square root of negative 1. 245 would be what? What times what is 245? Again, if you need to see your factors, do your factoring tree. My factoring tree is up here. 245. What goes into 245? 5 and What times 5 is 245?
49.
49. It should ring a bell. What is this? There you go. So it's going to be now square root of 49 times square root of 5 times square root of -1. This is 7. You guys already said it. So it's 7 square roots of 5 times I. I is going to be written in between 7 and and our beautiful radical. So I'm going to write it as 7 I square roots of 5. And this is the way that it's written. So it's always that value that's outside as a factor, I, and then the radical goes at the end. Okay. All right, go ahead and try square root of -48 and square root of -175. Let's see what you guys get.
Break it down apart to figure out.
Okay, so I have,
I would use 5, -175, 175, and then I would use 5 and 35.
so you're doing the bottom one, okay. So it'll be 175 times the square root of -1. And this is now square root of,
5 squared,
so it's 5 squared, so it's 25 times square root of
7,
7 times square root of
1.
-1.
And that's 5, square root of 7 times, square root of -1.
Which is
5i square root of 7.
5i square root of 7. Raise your hand if you agree. Yeah, you agree? Okay, that's correct. Yeah, because we have 175 square root of 7, and we have beautiful 25. So 25 and 7 are factors of 175, and also that beautiful -1. We take out that -1, and we leave that beautiful 7 and 25. All right, Caleb, pass it on.
Pedro,
All right, Pedro. How do I do this one? Square root of -48. Okay, so -48 and square root of -1.
and then 16 and 3.
So we did square root of 16 times square root of 3 times square root of -1.
Final's gonna be 4i square root of 3.
Square root of beautiful 3. Raise your hand if you agree. Yay, awesome. Okay. All right, I give you guys your beautiful worksheet. We have about 20 more minutes yet. Yeah, 20 more minutes left. So you guys can go ahead and finish this either in class or whatever you don't finish becomes homework. Okay. No, todos. All of 1 through 20. No, no que chinchampú. Ay, ay.